So we have to make sure that we can always solve equations. So I'm going to ask you in the warm-up to solve the following equations. It's up to you if you want to check or not. Remember the steps. Change subtraction to plus to the opposite. Deal with parentheses first. Move the variable from the right to the left-hand side of the equal sign if you need to by adding the opposite. Move the piece without the variable to the other side by adding the opposite. And get rid of the number in front of the variable by either multiplying or dividing each side to cancel it out. First problem, when you solved it, you should have gotten -3. Second problem is +3. 3 actually works out to be no solution. You should have ended up getting 6 equaling -2, which is not true, so it's no solution. And the last one is all real numbers. You should have gotten your variables to cancel and -14 equaling -14. Because the two numbers are equal, we go with all real numbers. We're going to be looking at scientific notation today. All scientific notation is a different way to write things. Okay, it's a different way to write really, really large and really, really small numbers. So all it is today. We're not adding or subtracting, multiplying or dividing anything. We're just writing numbers differently. The reason it's called scientific notation is it's used a lot in the scientific field because they're the ones that typically work with really, really large or really, really small numbers. If you're trying to find the weight of an ant in pounds, that's going to be a really, really small decimal. If you're trying to find the distance from the Earth to the Moon in centimeters, that's going to be a really, really, really large number. So this is kind of almost like shorthand or a way to make it smaller. So the notation, how these things are written. Standard form is one form of notation. It's what you're used to. A number written with all the zeros. 36 million or 0.0000045. We write all those zeros out. Scientific notation, on the other hand, it condenses it and it gets rid of those zeros. And in order to get rid of the zeros, it uses the 10. Because to move from 0 to 0, or to move from place value to place value, from the tens to the hundreds to the thousands to the 10,000s, what you're actually doing to move those place values is you're actually multiplying by 10. So scientific notation is always written as some number times 10 to an exponent. So the times 10 is always going to be there. The pieces we're going to be working with are the numbers in front of the multiplication sign and this exponent value. That's really where we're going to be focusing on. So we're going to start and we're going to look at going from standard form to scientific notation. How do I take numbers that are written the way I'm used to? How do I write them in scientific notation? And there are 4 rules, 4 kind of statements that will help you. Okay? If you end up in scientific notation with a positive exponent, it means that the number you started with is larger than 1. So if I'm starting with a number bigger than 1, I need a positive exponent at the end. If I'm starting with a number smaller than 1 and between 0, I need a negative exponent. The negative just tells me I'm looking at a really, really small number. Step 3 is how we actually do it. We're going to take the decimal point and we're going to move it so that there's only one number that is not a 0 in front of that decimal point. One number between 1 and 9 has to be in front of the decimal point. 10 cannot be in front of the decimal point because that's 2 numbers, a 1 and a 0. 13 cannot be in front of the decimal point. That's 2 numbers, a 1 and a 3. It can only be one number between 1 and 9. You can have negative values in scientific notation, and that's entirely different from negative exponents. If the value of the number itself is negative, you just bring it down negative in the scientific notation. It's not actually going to change the process of anything. So we're starting with 120, oh, I can't think today. Hundreds, thousands, millions. So I'm starting with 120 million. Currently my decimal point is back here behind the 0. I need to move it up here between the 1 and the 2. Because remember, I can only have one number in front of my decimal point. Times 10. It's always going to be times 10. I'm looking for the exponent, and I'm looking for the number in front of the multiplication sign. We're going to count now from where my decimal point started to where it's going to end up. 1, 2, 3, 4, 5, 6, 7, 8. I moved 8 places to the left. Because I went to the left, my exponent is positive. Also, my number is bigger than 1, and numbers bigger than 1 get a positive exponent. In front of the multiplication sign, you write all numbers until you hit the long row of zeros. There's always going to be a long row of zeros, and when you hit that long row of zeros, you stop writing in front of the multiplication sign. There isn't a whole lot of work with these, but I do need to see the little loop-de-loops to show me that you're counting. It is actually very easy to get lost in these sort of problems. Number 2, my decimal point's at the end. I'm moving it between the 5 and the 6. Times 10 is always standard, and now I'm going to count. 1, 2, 3, 4, 5, 6. So my exponent is 6. 5.643 goes out in front. I have to write the whole way till I hit the long row of zeros. 3. My decimal point is after the 0. It needs to go between the 2 and the 3. Counting 1, 2, 3, 4, 5, 6, 7. 2.35 till I hit the long row of zeros, and that negative just moves over. It's just telling me that the entire value is negative. Number 4 is our first one looking at going the opposite direction. So I already know where my decimal point is. I still want one number in front of that decimal point. So I don't want to move the decimal point the whole way behind the 2, because then I have a 1 and a 2 in front of it. And I don't want to stop before the 1. So I'm going to count, but I'm going to count backwards now. 1, 2, 3, 4. Still times 10. To me, it feels like I'm going backwards. And that going backwards motion reminds me that it needs to be a negative exponent. So you can remember it 3 ways. Our number is smaller than 1, so therefore it's a negative exponent. When you count, if it feels like you're going backwards, that should tell you it's a negative exponent. Or the fact that I'm moving towards the right should tell you it's a negative exponent. And again, all the numbers before the long row of zeros, so 1.2. So here's some for you to practice. Go ahead, try them on your own, and then we'll regroup and go from there. So, first one on the practice, it should be 8.91 times 10 to the positive 9th. We're not counting zeros, we're counting decimal places. 2, 1.7 times 10 to the 3rd. 3, 9.5 times 10 to the negative 4th. Now we're going to go the opposite direction. If we're in scientific notation, how do I get back into standard form? And again, it's all about moving. But now instead of getting rid of the zeros, we're going to add the zeros back in. Positive exponent again means that my number is greater than 1. It's going to mean that I'm going to move my decimal point right this time. Positive exponent, movement to the right. Negative exponent, movement to the left. And again, if I have a negative in my problem, I have a negative in my answer. Oh, so my exponents are all screwed up. So the first one, 3.2 times 10 to the 7th. Write the number down first, 3.2. Remember that a positive exponent means that I'm going to the right, and a negative exponent means that I'm moving to the left. So this 7 tells me I'm going 7 places. It's positive, so I'm going to the right. 1, 2, 3, 4, 5, 6, 7. All these open little holes get filled in with zeros. You do need to take it then and write it all nice and neat, putting the commas in where they belong. Second one should be negative 1.85 times 10 to the 6th. So negative 1.85. My 6 is positive, so I'm moving to the right. 1, 2, 3, 4, 5, 6. Writing it all nice and neat with commas is negative 1,850,000. And this should be 8.96 times 10 to the negative 5th. So my exponent somehow traveled up there. So this one's got the negative exponent. Still write your number like normal, 8.96. The negative exponent tells me I'm going left 5 spaces. 1, 2, 3, 4, 5. Put zeros in the loops and go ahead and write it all nice and neat. You do not need to put a 0 in front of the decimal point unless you would like to, but please make sure I can find your decimal point. Do not make it so small that I can't find it. Some for you to practice on, 4.81 times 10 to the 4th, 9.83 times 10 to the negative 2nd, and then this one's 10 to the 8th. This one should be 41,800. 2 should be 0.0983. And this one should be negative 789,400,000. And then we're going to skip this slide because we're going to talk about that tomorrow. So your homework tonight is a worksheet. If you don't have it in front of you, you should be able to access it from my website.